Hello everyone, this is the physics. My name is Daniel Nidinaev, and today we have a lesson about Newtonian classical mechanics. Also sounds like Newton's laws of motion. And during this lesson we will study about Newton's first, Newton's second and Newton's third laws. Please be attentive and let's get started. First of all, please introduce with my outline for this lesson. First, we are going to introduce two laws of classical mechanics, and after that, we will study about Newton's first, second, and third laws. So after main parts, we will sum up this lesson by using this short animation. So, and here we go. And first is introduction to laws of classical mechanics. And the following introduce the basic concepts of classical mechanics. To simplicity, it often models real-world objects as point particles, objects with negligible size. The motion of a point particle is characterized by a small number of parameters: its position, mass, and the force applied to it. Each of these parameters is discussed in turn, and in fact, the kind of objects that classical mechanics can describe always have non-zero size. The physics of very small particles, such as the electron, is more accurately described by quantum mechanics. Objects with non-zero size have a more complicated behavior than hypothetical point particles because of the additional degrees of freedom. For example, a baseball can spin while it's moving. However, the results for point particles can be used to study such objects by treating them as composite objects made of a large number of collectively acting point particles, and as a result, the center of mass of composite object behaves like a point particles. And here we have Newton's first law, and I told you that there are Newton's three laws of the motion, and this is the Newton's first law. So, and Sir Isaac Newton published three laws in the 17th century, and in this slide we are going to talk about Newton's first law. This law does an introduction of motion of the object and the force acting on it. In other words, it deals with the motion of an object and its relation to force. And Newton's first law defined as that a body remains in the state of rest or uniform motion in a straight line unless and until an external force acts on it. And Newton's second law. Newton's second law states that the acceleration of an object depends upon two variables: the net force acting on the object and the mass of the object. The acceleration of the body is directly proportional to the net force acting on the body and inversely proportional to the mass of the body. It means that as the force acting upon an object is increased, the acceleration of the object is also increased. And as the mass of an object is increased, the acceleration of the object is decreased. And this is the Newton's second law. And what about Newton's third law? From this illustration, as you can see in the first illustration, action-reaction forces which act into the gun and to the bullet. And the action force which applied to the bullet accelerated and the reaction force, recoil force on the gun. And also in the second illustration about foot, action force, foot pushes down and back, given by blue lines, and the reaction force, floor, pushes up and forward. This is the reaction force. This is the pairs of the action and reaction forces. And the last illustration given about boy action is the boy's feet exert force on boat, and the reaction force, boat exerts force on feet. So by summarizing these three illustrations, we can say that the Newton's third law may be defined as when one body exerts a force on the other body, the first body experiences a force which is equal in magnitude in the opposite direction of the force which is exerted. So, and in this level, I want to show a short animation about forces which act into the body and what is the net force. So, in just a second, I need to change my presentation. So as you can see here, given the free body diagram for the object, and to this object or to this box, right now acting only two forces, gravitational force and normal reaction force. And these two forces, under these two forces, this box in a condition of balance. But if this box starts moving in some direction, the forces which act into this box will increase. For instance, let's just see it. As you can see, the sum of the forces which act into the object is directed to the right and equal to approximately 600 newtons. And from this table, data table, if you see the object mass is 100 kilogram and the kinetic friction coefficient is 0.3 and the static friction coefficient is 0.5. It means all objects under the gravitational constant and under the normal reaction force also experienced some amount of force, and this force is called like external forces. And here this man exerts some amount of force to the box, and under this force this box directed to the some amount of distance from the initial position. So, and in this level it's time to sum up this lesson, and that's why I need to change my presentation. Just a second. So, and in a conclusion, I want to tell you about Newton's laws of motion. And there are three physical laws. And this is the Newton's first, second, and the third laws. Also, they describe the relationship between a body and the forces acting upon it, and its motion in response to those forces. More precisely, the force law defines the force qualitatively. The second law offers a quantitative measure of the force. And the third asserts that a single isolated force does not exist. And these three laws have been expressed in several ways over nearly 3 centuries and can be summarized as follows. And the first law is, in an inertial frame of reference, an object either remains at rest or continues to move at a constant velocity, unless acted upon by a force. And what about second law? Also in an inertial frame of reference, the vector sum of the forces F, or net force, on an object is equal to the mass m of that object multiplied by the acceleration a of the object, and can be summarized by the equation where F is equal to the multiplication between mass of the object and its acceleration. And the third law is that when one body exerts a force on a second body, and the second body simultaneously exerts a force equal in magnitude and opposite in direction of the first body. So, and in this level, I think you have any questions. That's why if you have any questions, you can ask me right now, and also be informed that you can find out more details in the physics book, Pearson Education, and also you can observe the simulations related to laws of motion or Newtonian classical mechanics by the link of www.fred.colorado.education. So, and if you have any questions, just ask me right now. If you don't have any questions, it's time to say goodbye. Thank you for your attention. See you in the next time.